हरि करना।
Now let's deep dive into the random variables. So informally, a random variable, I told you RV, we say R dot V or capital RV. So capital X denotes the possible outcomes of an event. That's what a random variable capital X. And it can be discrete, finite, many possible outcome or outcomes are continuous. If it is discrete, the outcomes are finite. If it is continuous, then the outcomes are continuum. You can place them on continuum. Okay, now let's see different types of random variables, or you can say random variables which are used with different types of distributions. So we will begin with discrete. First, let me write down the random variables. First one, discrete random variables. So discrete random variables, variable can only take on a finite or a countably infinite number of values. Some examples of discrete random variables include number of heads in multiple coin tosses, and number of children in a family, number of children in a family, number of cars sold in a month, number of times a website is visited in a day. So this is a discrete random variable, and it's and some examples of discrete random variables. This is in a mathematical form. There I have put it in normal form. So in general form, this is the mathematical form. X is equals to 0, 1, or heads or tails, denoting the outcomes of coin toss. And X belongs to capital X, obviously your random variable. A discrete random variable belongs to set of 1, 2, 3, 4, 5, 6, denoting the outcome of a dice roll. So these are the example, and this is how you represent, because these are all discrete events. The outcome is also discrete, so that's the reason the graph is represented this way. The graph is never continuous, it's you represent like this. Okay, so this is the mathematical representation of it. Capital X belongs to a respective set. So next, this is done, then we will get into the second type we have is continuous random variables. Continuous random variables. So a continuous random variable can take on any value within a certain range. Some examples for this, some examples of continuous random variables include height. Let me write it down like this. Examples. Okay. Examples: height of height of individuals in a population, time it time it takes to complete a task, weight of products produced in a factory, temperature of a room. So this is what is our continuous random variables. Let me show that now. So some examples of continuous random variable. This is how we represent. In spite of putting in sets, we put it in a bracket. So x belongs to capital X, that to random variable always denoted with the capital alphabet. So capital X belongs to 0, 1. So denoting the bias of a coin. And X belongs to R, denoting the heights of students. Students in a particular class. And the graph, this is how you see. This is a discrete random variable, and this is continuous random variable. And that you can make out here, the difference between both. Okay. So continuous random variable. The third one we have here is binomial random variable. Binomial random variable. A binomial random variable is a type of discrete random variable that represents the number of successes in a fixed number of independent trials. So some examples for this binomial random variables include number of defective products in a sample of products, number of students who pass a test out of a fixed number of students who took it. Then we have one more example. Number of times a coin comes up heads in a fixed number of tosses. So next example that we have, next stat we have is Poisson random variables. So a Poisson random variable is a type of discrete random variable that represents the number of events occurring in a fixed interval. So this represents the number of events occurring in a fixed interval of time or space. Given the average rate of occurrence, given the average rate of occurrence of the events, let's see some of the examples here. So number of car accidents in a day in a certain area. So number of car accidents in a day in a certain area, and number of customers entering store in an hour, number of calls received by a call center in a day. So these are the other types of random variables. However, you can have more of it based on the distribution we will be using. So these are just a few examples of random variables, and there are many other types of random variables used in statistics and probability theory. Understanding random variables is crucial for statistical analysis and modeling in many fields, including finance, engineering, and social sciences.